this afternoon's competitive advantage talk. I want to welcome Tom Slow, CEO and founder of Nerve. And he's going to be presenting a new role for machine learning in sponsorship management. Today's session will be 30 minutes. There will be some time for Q&A, depending on how Tom wants to handle it. Tom, why don't you take it away?
Thank you, sir. So what we do at Nerve is, through automated fashion, search through the actual pixels in the video and understand everything that an analyst seeks to try to mine from that particular data. We can identify, obviously, branding and different unique objects, athletes, obviously in this case, different types of branded product. Fundamentally, we developed this technology going back as long as 5 years ago, and initially targeted applications in the U.S. intelligence community and Department of Defense. In fact, the investment arm of the intelligence community is actually an investor in the company. But the last 18 months, we've pushed this technology into commercial endeavor, and obviously struck a partnership with Wasserman Media Group about 7-8 months ago or so, whereby we're their exclusive supplier of brand media measurement using the fundamental video search technology that we developed before. So we're actually looking, and so the big distinction here is that we're not using metadata or manually tagged information in order to search through the media. We're looking at the pixels themselves in an automated fashion. The system understands the thing you want to search for, and then it searches through the video repositories, or in some cases live streams, super fast to be able to deliver back substantive, consistent information about where the particular brand is located, how big it is, and actually in addition, the level of clarity. And I'll get into kind of that in a little bit, and I'm going to show you some demos as well. So functionally, you can look for even an individual's kind of dress, or it doesn't have to be actually branding, although that is the major focus, obviously, for obvious reasons. So here you see it's a search by example methodology, and right now we're searching for a dusty car kind of in the desert environment. But basically, as an analyst, you crop out one or more image examples of the thing you're trying to find. The software automatically understands the way that looks, and then compares it in rapid fashion to the video repository that you're searching. It gives you back ranked results, very Google-like. So the start time to the end time, the likelihood that it is actually the thing you're searching for, size on screen, and position. But obviously, and one big point here is that we do this very efficiently. So we're actually able, on a single computer of kind of off-the-shelf hardware, to actually search an hour of video in under 5 seconds. And so once you push in more machines, you can actually get sub-second search responses on hours of video, which is pretty exciting, actually. And that's, I'm going to get to a case study, and I'm going to tell you how long it took us to actually get a huge number of brands across a NASCAR race, but I'll get there in a sec. Because of the fact that it's automated and it's not humans just looking at the video, you can do bigger things. You can measure, an entire season of NCAA football and compare how Nike did versus Under Armour versus Adidas. You can ask more questions, basically. So speed and scale is key. Being able to come to those numbers really fast, and being able to scale the solution based upon the data volume of video content. Consistency is key as well. It's a highly accurate system, obviously, particularly because of the fact that it's put into use by the U.S. intelligence community. But one thing that's left out frequently when talking about accuracy is consistency. The same machine is measuring the same, all these different datas in the same way every single time. That's vastly different than when you have 100 or 1,000 or 5,000 different analysts with different error profiles associated to those individuals. Did they get their coffee first thing in the morning? Are they a little sleepy? What happened to them? The data that they're producing is vastly different, not only day to day, but with each other. Whereas in this particular case, the profile of any type of error or correct answer is always consistent. So when you're starting to combine these data together, it's not additive from an error perspective, which is really, really important from a data quality perspective. And then lastly, context is everything. We don't, because of the fact that you can target the system to search for, as an example, Nike, or we can target it to search for Nike on jersey, Nike on cup, Nike on billboard, and then build the brand up from brick by brick. We are able to layer in greater levels of context to the actual assessment of the value of the advertisement, particularly when you weave in clear versus unclear reporting, because you might get 18 minutes during that football game of exposure, but it's really important to understand whether somebody actually saw it and would be able to absorb it within reason. So as I noted earlier, we are partnered with Wasserman Media Group, and so NERV's job is to do these assessments, to understand what's in that actual content, and then in rapid fashion turn that data back over to Wasserman, where Wasserman takes it and places values and does higher level kind of assessment. So I'm going to give you a little bit of a case study that we did for the Daytona 500. I'm going to note that the 500 over the race weekend completed, I think, Sunday night, and by Tuesday midday we had already generated all of the data and the reports associated with that particular sporting event. And we analyzed not only the race itself, but also kind of affiliated different types of broadcast. So what we ended up with there, obviously significant audience. We calculated that it was our software calculated 4.5 minutes per car of exposure, average duration of brand exposure, and total visual value of 15 million. So digging in a little bit deeper, FedEx obviously was a clear winner, with almost 23 minutes of clear exposure, which was pretty much everywhere. They did a great job with their branding. They were able to achieve a higher percentage of clear exposure than a lot of the other brands that were out there. Obviously average duration, Jimmy John's did pretty well as well. Chevrolet came up close. But despite the fact that, in this particular situation, Clint Bowyer didn't do so well, 5 Hour Energy still did pretty well, at least as assessment from, brand on screen. So at the end of the day, FedEx obviously clear winner, and here's the ranking. And that's all I got for you. Questions? Yes, sir.
Yeah, I was wondering, sort of combining the machine learning portion of it, do you guys do any, when speaking of sponsorships, any assessment of when certain types of content might be best received by someone who's viewing it? Is there any attempt to sort of parse that out?
That is something that right now is done in a qualitative way by Wasserman. From our side, we're very heavily focused on, quantify what you want to find in that content, and we'll find it really, really fast. So if that can be quantified, through a separate set of visual search queries, finding, as an example, an athlete associated to a particular brand, we can, do that 6 ways from Sunday. Yep.
Can you go back to the last slide?
Yeah, sure.
Yeah.
Oop, right there.
No, but
Next one.
yeah. So what's the value for the numbers?
That was the calculated value. So the 1.9 million for FedEx, as an example, was a calculated value based upon the total exposure size on screen that they got, based upon the methodology that Wasserman and NERV are bringing to market. Yep. Let me show you a demo. So this is one of many interfaces that our different and various customers employ. Obviously web-based interface, everything's remotely hosted, actually, on our servers up in Buffalo, New York, where we're headquartered. Everything's project-based, so this is an interface that, an analyst uses. You upload your media over here. Once it's in, then you can dump that into a project which has all of the media you're going to search and all of the search queries. So I'm going to open this social media project here. You can obviously view the media if you're interested. This is just 40 minutes of kind of a mashup of different types of social media that one of our analysts put together. So what we're going to do is search for Starbucks, Louis Vuitton, Veuve Clicquot, and Sun-Maid raisins. These were obviously assembled by, these search queries were obviously assembled by an analyst internal to NERV, and I'll hit search. You'll see status is queued, status finished. That's how fast it looked at every single video frame inside of 40 minutes for 4 different things. And so obviously sub-second search result in that particular situation, that's about 85,000 separate images that it was able to churn through and generate substantive data. So that is, again, the time from when it appeared, the time when it disappeared, where it was located, and the size on every single frame. So there's lots of visualizations in here, but not to belabor the point, and we can get into it with questions, obviously, but you can then go in and view the different video clips that are automatically surfaced based upon all of the visual similarity. And you'll see that it's able to capture different versions of that, in some cases heavily occluded, blurred, so on and so forth. You'll see that it comes with an understanding of when that begins, when that ends. Sir?
Question. Do you guys need metadata to search some of these images?
No, we don't, but you can use it to automatically generate the metadata. So we can actually go back, and obviously there's a small integration effort to make sure we conform to the standard of the particular media company, but we can annotate so somebody can use the software to search and then dump that information into the metadata stream and then do a keyword-based search later, because every visual search query, which is just an assembly of, in this case, Starbucks logos, a handful, 1 to 5, 10 maybe. After that point, you can actually attach keywords to it, Starbucks, coffee, that type of stuff. And then if you want to be able to search based upon keywords, the way that a traditional media asset management system does, then you can do that too.
But before, if you're not using the keywords to search, how are you guys doing it?
It's all based upon the pixels. It's all automated recognition, high-level machine learning technology that I and my partner developed originally, and our team has continued to advance. Thanks. Yes, sir. We are using GPUs, so we use NVIDIA. We're actually partnered with NVIDIA. So one of the things that we did, my background obviously machine learning, so I'm a super geek, and been doing this now for a little over 21 years. 2/3 of my career is focused in the US intelligence community, serving technical problems there, another third in advertising. And so we just saw, me and the co-founder saw that, these imagery and video analysts staring at screens, given tasks they cannot reasonably complete. We wanted to create a capability that would speed them up at being able to do, their jobs better. And so we invented this thing, and there were 3 primary criteria. Number 1, the softwares that were out there just were surfacing too many false positives. They weren't accurate enough. Another problem is that they were really hard to use. They needed somebody with like an advanced engineering degree to sit in front of the screen and kind of tweak parameters to make sure it operated in linear fashion. And the dollars and cents of that just don't kind of pan out. There's not enough engineers to place against that problem. But thirdly, probably the most important part, is that they're just not that efficient. You can get, in traditional computer vision machine learning algorithms, in some cases 5 to 10 times real time or something like that per machine. Oh, they're very accurate, like a deep neural network, and we do use some level of deep in what we do, but we actually perform on a machine-by-machine basis. On a single machine, we perform at 1,000 times real time. So what we had to do is essentially take a number of pre-existing kind of computer vision machine learning algorithms, in addition to inventing some of our own, and assure that all the branch decision making, because anytime you say if this, then do that, and if not, then do this, that destroys parallelism, and that destroys speed. And so we basically wrap this into an entire pipeline where there is none of that from the beginning till the end. And at the last moment, that's when we actually make a decision on which video clips you get. And that's why it's so much faster.
Wow, that's impressive.
A couple orders of magnitude faster than the nearest competitor, at least, a little bit more. So, So anyway, so this gives you a sense for kind of the types of search results you get. All of this is updated in a database. And so from there, you can either export the database and then into direct reports. We are in the process of adding to this capability an automated reporting engine so that it just kicks out the charts and graphs right away. I'll just show you one other thing that we're doing as well on the live streaming front. I'm just going to give you, so this is in partnership with Wadio, which is a Internet of Things company out of New York City. They actually stream segments of this Yankees game to us from their servers in New York. They hit our servers over in Buffalo. And what's going on here is that as the streams are playing, it's searching for these things over on the lower left. And so you'll see it just identified, oh, there's a Yankees logo that looks like that. And then, oh, by the way, we're going to chart that on a graph and show you what the likelihood is that you are actually achieving a certain amount of branding over time. So we're really taking this from let's get your data after the event really, really fast to let's give you your data while the event is actually going on. Yep.
I'll go anyways. From an advertising perspective, is time a critical component? And if you allow more time for your algorithm, would you see, what could you do if you weren't trying to do, an hour and 4 seconds, but rather you gave yourself a minute to do?
Basically more search queries. Essentially, you could just execute many, many, many more search queries. And that's part of the value proposition, I mean, particularly when you start talking about brand confusion, you may be, under contract with one brand, but for them to understand, as an example, what are all the other brands that are actually visible during that time, you may have to search for 50 or 100. And speed factors into that because we just don't need to throw a lot of compute horsepower against the problem in order to actually come out with those understandings. So. Yep.
Do you have any just streams that you're looking at all the time? So like let's say ESPN or some of those channels, or is it all just fed by the client who's looking at it?
It's changing. So off the start of our partnership, we really just did, you start with, here's a project, here's the 10 games, go off and measure all that information, right? And then pump out a report. It's changing because we're rapidly gravitating towards we're moving towards more syndicated type scenarios and kind of larger, broader kind of league type engagements, which is a natural progression just in the partnership and also for us and Wasserman as a company. Yes, sir.
Is it dependent on color of your algorithm? I saw that it didn't catch the Yankees logo in the green field, or do you have to just put in multiple?
You put in multiple queries. So you see how you also have a Yankees that's looking like that. Color is relevant. If, though, as an example, you submitted both of those Yankees into the same thing, conceptually the algorithm will understand these things are the same thing, so I should understand both of these things. But if you really want to target, coming back to the example of building up your brand brick by brick and saying, hey, I only want it when the Nike logo's on a cup versus on, a jersey, it's kind of important to be able to target the software in that direction. And that's the way that it's used currently. Yep. Sir?
So my question is sort of along the same lines. If I want to have your software search for like a Starbucks logo, do I have to give it many examples?
Yes.
And what are the typical, like how many examples do you need and what kind of variety?
What you can do is, so you're going to go and submit, so I'm going to scroll back to the results here. So in this particular case, that was one of the examples that was submitted, okay? Usually, by the way, it's like you'll start off with 1 to 3, okay? So it's not like a deep learning algorithm that requires about 500,000 minimum, which is really problematic. We had to cast the algorithm this way because of the fact that when working with the intelligence community, they can't give us their data. It's all classified. So they need to be able to form those search queries, and they're not going to be sitting there and putting in 500,000 image samples of that thing. So we had to create a way that it could make the most out of the sparse data it's got. The upshot is, though, is that when you go down here and you start looking at this, you're like, hey, this is really exactly what I'm looking for. There's a plus and a minus button there. Let's say that we did our search query and you didn't get what you wanted. Well, then you hit a minus button. That tells the system, oh, well, all of the data in this particular clip is really irrelevant to me, and that further educates the algorithm on a negative example. Likewise, let's say that you don't want to necessarily look into the content and crop an image out of the raw content because maybe it's located an hour in or something like that. So you go to Starbucks website and you peel off a vector-based graphic of their logo and you submit it. Well, obviously that vector-based graphic is not going to look or appear identical to something like that. There's lighting differences. It's on a curve. There's of the mug. But you will still surface some image examples of that, some video clip examples of that. And when you do, you can hit a plus button and say, no, that is exactly what I want in the content, and then you iterate. And in practice, it's at most 3 to 5 iterations or so, but the responses are a few seconds each time, so it's not really that big a overhead. Yes, sir. Yep. Yeah, exactly. That's where we're headed. Any other questions? Oh, there you are. I can't see you because of the lights. Yes. Yeah. Currently, we track specific people. But and it's not only based upon facial appearance, it's also based upon any type of clothing they're wearing as well, jersey number. It also, by the way, reads as well as sees. So it can see a Starbucks logo, but it can also read. If Starbucks was printed there, it would actually extract the text from that in the wild. Yep. Any other questions? Thank you, folks.